In this video, I am going to talk about strength of correlation between two variables. We can say a linear correlation is strong if the points in its scatter plot fit well in a straight line. Now, let's look at these given scatter plots here. So, on the first one here, let me draw a line. When we draw a base fit or a straight line, these dots here are very close to this straight line, this one here. So we can say that this shows the strongest correlation. And for the second one here, let's try to draw a straight line. Now we can see that these dots here are somewhat close to this straight line here, but not like one on the previous one, but not like on here. So this one shows that there is some correlation, but not as strong as the previous one. For the third one here, let's try to draw a straight line. This one on here, there seems to be no correlation at all. No matter how you draw a straight line, they don't fit with these points here. So it is the weakest one among these four scatter plots. Finally, for the last one, here, let me draw a straight line first. It seems that correlation is quite strong because when you draw this straight line, these points here are somewhat close to this line. So we can say this one here shows the stronger correlation. Next, we look at a way to measure strength of linear correlation numerically, and we call it linear correlation coefficient. We denote it by R. R ranges between -1 and 1. Next, we look at a way to measure strength of linear correlation numerically. We call it linear correlation coefficient. We denote it by R. R ranges between -1 and 1. When R is close to -1, we have a strong negative linear correlation. A scatter plot may look like this. Let me draw a scatter plot here. This is our x-axis and this is our y-axis, and our scatter plot may look like this. When R is close to 1, we have a strong positive linear correlation, and let me draw a scatter plot here. And our scatter plot may look like this. This one is our x-axis and this one is our y-axis, and our scatter plot may look like this. When R is close to 0, we have weak or no correlation, and a scatter plot will show no relation between x and y. Data points on the plot are randomly scattered, and the graph may look like this. So let me draw a graph here. This one is our x-axis and this is our y-axis, and our scatter plot may look like this. Here we are supposed to match the given values of R with scattered plots. Let's try to find a match for this. For the first one here, it looks negative strong, so we pick R equals to -1 from given R values. Now let's look at this one here. This one looks positive. This one looks positive but not very strong, so we pick R equals to 0.75 from the given values of R. Now, let's look at this one here. This one seems to have weak correlation between x and y. Since points do not show any linear pattern, so we pick R equals to 0.016 from given R values. Finally, let's look at this last one here. So this last one here looks positive is strong. So we pick R equals to 0.97. Here we have this data, and I will show you how to find the values of R correlation coefficient using formula, TI calculator, and Excel. First, let me show you how to find R using formula. We have this formula here, and looking at this formula here, we need sum of xy, sum of x, sum of y, sum of x squared, sum of y squared. So now let's make a table like this and let's try to find our values for this column, for all these columns, and let's try to find the sum of all these columns here. So 5 times 7 is 350, which is x times y. Our x squared, our x is 5, so x squared is 25. Our y is 70, so our y squared is 4900. For the next row here, for this one here, our xy is 3 times 65, which is 195. And here x squared, which is 3, so we have, for x squared, we have 9. And for y squared, our y is 65, our y squared is 4225. Now let's try to find the rest of the values on here. So I have posted all these values here. Now all we need to do is find the sum of these columns here. So let's try to find sum of x, which is 29. Sum of y is 390. Sum of x times y is 2170. Sum of x squared is 181. And sum of y squared is 27850. Now, once we have these values here, all we need to do is substitute these values into this formula here. Let's do that. So our n here is 6, 1, 2, 3, 4, 5, 6. So I will just put that there, 6. Our sum of xy, which is this one here, 2170. So I will put that there. Minus our sum of x is 29 times 390. Sum of y is 390. So that's what I'll put. So we are done on the numerator part. For the denominator, we have square root, then our n is 6, sum of x squared, so which is 181, so I will put that there, minus this, which is 29 square, times n is 6, so this value here is 27850, 27850, minus 390 square, 390 square. Let me pull that to there. When we do this math, this whole thing comes out to be 0.892. So, therefore, correlation coefficient R equals to 0.892. So this is what we found using formula. Now let me show you how to find the correlation coefficient R using calculator. For that, let me pull up my calculator on the screen. Now go to second catalog. Then you have to turn your diagnostic on. So let's go all the way down until we see diagnostic on. So this is what we need to select, diagnostic on, hit enter, then hit enter. You should see this message on your screen. Once you see this message on your screen, then you need to go to Stat, then Edit, select Edit, then hit Enter. So now you will be entering your X values in your list 1 and your Y values in your list 2. So that is 5, enter 3, enter 9, 4, 1, 7. So I'm done entering my X values. Now let's enter our Y values. So that is 70, 65, 85, 50, 30, and 90. Now, once we are done entering our data, then you will need to go to Stat, then highlight your calc. Use this arrow key to highlight your calc. Then use this arrow key to go to number 4, where you see this one, linear LINREG parenthesis AX plus B. So that's what you need to select. That is number 4. Then hit enter. So on here, your list X list should be list 1, your Y list should be list 2. That's what it is here. So we don't have to do anything here. Then come all the way down here, then hit enter. If you look at this one here, that's your R value, which is 0.892. And this is exactly what we found using formula also. Now, let me show you how to find the values of R using Excel. So let me pull up my Excel up on the screen. So here I have already entered my data in these two different columns. So this column here and this column. So now for us to find R here, what you need to do is type in equals, then type in CORREL, then put parentheses here. So for your array 1, so it says array 1, go here and select your X values. Then type comma for your array 2, go here and then select your Y value. Then close your parentheses, then hit enter. So you have this number here, which is the value of R, and this is exactly what we got using calculator and also using formula. Thank you for watching. We hope this video was helpful. Please like and subscribe our channel. We will be bringing more and more videos on variety of topics.